I like to be able to use existing projects in other projects. This makes it easy to connect up modular components like Legos into an application and speed up development while maintaining separate projects. In this video, I'll cover 6 different ways to do this with CMake. This video assumes you have a basic understanding of CMake. If you don't know anything about CMake yet, I have a CMake crash course video that you can go watch first. It takes about 14 minutes, and then come back to this one and take a look. In this video, we'll cover how to use a CMake project and another CMake project in 6 different ways. Number 1, adding the dependency project as a subdirectory of the dependent project. Number 2, exporting targets from the dependency project and importing them into the dependent project. Number 3, importing exported targets using a command line parameter. Number 4, making use of the user package repository. Number 5, installing the dependency project and using find package to load it. And lastly, number 6, creating an installable package, installing the package and using the dependency from the installed package. We'll also cover how to uninstall the package. We'll need to use several CMake commands to do all of this. We'll cover target include directories and export and install commands, include, find package, set and generator expressions for install and build interfaces. We'll also cover several built-in CMake variables, including CMake current source directory, current binary directory, user command line parameter variables, CMake export package registry, install prefix, cpack generator, cpack Debian package description, and maintainer. And we'll use the configure package config file function from the built-in CMake package config helpers module. Let's dive in. First, let's set up a test project. We'll make a top-level directory called CMake Depends with 2 subdirectories, depend and proj. Then we'll make a top-level CMake list.txt file for the CMake Depends project. Remember our 3 basic lines for a CMake list file: CMake minimum required, project, and then the targets. For targets, instead of adding a library or executable, we'll add the subdirectories depend and proj, which will contain their own targets. Now let's create a simple library in the depend subdirectory. We'll create a header and a source file for the library. This library will just contain a single function, mySum, that returns the sum of the 2 input values. The subdirectories will have their own CMake list.txt files and define their own targets. In this case, it'll be a library called mylib. Now let's create the project proj that uses the library mylib. We'll just include the relative path to the mylib header file and call the mysum function. We now need to create the CMake list.txt file for the dependent project. This time we'll create an executable target and we'll link to the mylib target. Here's an overview of our project structure as shown with the Linux tree command. And the project builds and links just fine. Here's a tree of the build depend directory. You can see all the files that CMake created. Here's the static library libmylib.a. And in the build proj directory, the executable target main. When we run it, it runs but has no visible output, which is expected, and no errors either. Now let's do this a different way. We'll delete the current top-level CMake list.txt file that adds subdirectories, and instead we'll modify the dependency, mylib, to be its own separate project. It's good practice to put library functions and classes in their own namespace so they don't collide with others in the global namespace. So let's do that now. For clarity, I'm going to rename the project name to something other than mylib, so you can tell when I'm referring to the target mylib versus the project mylib_proj. In order for a dependent project to use a library, it needs to know where to find the header files. We can specify this using the CMake command target include directories. We set the path to the header files for each target. In this case, the mylib library target and the header files can be found in the same source directory that we're in now. So we use the built-in CMake variable, CMake current source dir. Now we're going to export the library target to a targets file. We choose the name mylibtargets.cmake. It has to end in .cmake, and it's conventional to call it the name of the library followed by the word targets. We won't be needing the old build directory at the top level anymore, so we'll delete that. Now let's update the dependent project to use mylib as a dependency loaded from the targets file. An easy way to do this is to literally just include the dependency library's targets.cmake file in the CMake list.txt file of the dependent project. You can see I'm adding the build directory where the targets file will be created. Let's build the library in its own build directory and see that the targets file was created there. Uh-oh, I made a mistake. Looks like I forgot a close brace. Ah, there it is, typo. There's the mylibtargets.cmake file that CMake generated. And there's the static library, libmylib.a. The file contains all the information CMake needs to load the targets from another project as if they were built as part of the current project, like we did in option 1 with subdirectories. Remember, we put the function in its own namespace, and we specified where to find the library's header files, so we don't want to specify the path to the header files anymore. Instead, we can now include the header with angle brackets like we would for any other external library. And you can see the project builds and links successfully. Again, the project runs without errors but produces no visible output. Now we can do this yet another way. Let's get rid of the existing build directory for the library so we can start fresh. It's common to use a project directory structure that has an include directory for public headers. Public meaning they will be used by projects that depend on this library. Let's move our public header, mylib.h, to its own include directory. Here's our new project structure. Now let's update the path to the public header files for our target include directories command as well. And we rebuild the library project depend. Going back to our dependent project, we'll delete the existing build directory to start fresh here as well. The current include specifies an absolute path, which is pretty brittle. If we ever move where the library is located, our project will fail to build. We'll remove the path from our CMake list file. And instead, we can provide the path as a user parameter we'll call path to mylib targets that has the path to the library's targets.cmake file. Now, where we build our dependent project, we can provide the user parameter when calling CMake from the command line with -d path to mylib targets equals and the path to the mylib targets.cmake file. And we can still build, link, and run the program successfully. For the next option, let's start fresh again by removing the existing build directory. It's an easy change to add the library to the user's CMake package registry. We just add a few lines to the library CMake list file that tell it to first use the package registry, second specify which targets to export to the package registry, in this case just mylib, and lastly create a CMake config file. In order to create the CMake config file, we'll use a built-in CMake function from CMake package config helpers, a built-in CMake module. The function configure package config file takes as input a .in file and generates as output a config.cmake file. We just have to specify where the .in input file is and where to put the generated .cmake file. Both where to generate the .cmake file and also where to install it. We still have to create the .in file, which we'll do next. The mylib.config.cmake.in only needs a couple lines. We use a built-in command package init that is interpreted by configure package config file and replaced with the necessary package initialization. And we simply include the targets file we already generated before. That's it. Now we can build the library again. You can see there is a new mylib.config.cmake file in the build directory. On Linux, the CMake user package directory is in the user's home directory in a subdirectory called .cmake. If you look there, you'll see a packages directory, and within it, there will be a directory for each package exported by CMake to the registry. There's mylib. In each package-specific directory, there will be files that contain a reference to the location of the package's config.cmake file. There are two here for mylib because I did this already before. Here's the one we built just now with the correct absolute path. Now for clarity, we'll get rid of the existing mylib directory in the CMake package registry and rebuild the library so you can see it in action. When we look back at the package registry directory, a new mylib directory has been created by CMake, as well as a new file containing the current path to the mylib.config.cmake file. You can see that the path in the file is the absolute path to our dependencies build directory, where the mylib.config.cmake file is located. Going back now to our dependent project, we'll delete the old build directory and update the project to use mylib from the package registry. To do that, we just call find package like we would for any other installed package. And that's it. CMake already knows to look in the user's CMake package registry for packages referenced by find package. We can still build, link, and run successfully. Again, there is no output, but no errors either. This is a good sign. For the next option, there's a bit more we need to add to the library CMake file. Let's start fresh by clearing both the existing dependencies build directory and the CMake user package repository. We don't want our dependent project possibly finding our library through the previous builds or references. We'll also just get rid of the existing dependent project's build directory as well and attempt to rebuild. You can see that it fails to find the library's config.cmake file. That's good, since it means we have no leftover references to the library and we're ready to start on the next option. Going back to the library CMake list file, we're going to remove the lines that put it in the package registry so that we can't accidentally find the package that way. For this installation type option, we need to specify where to find the header files at build time and install time separately. CMake has a built-in way to do that using what are called generator expressions. You can see the syntax uses angle brackets, a parameter, and a colon separator, followed by the path to use for both the install interface and the build interface. The build interface is used by the internal parts of the library mylib, which mylib itself is built. The install interface is used by other projects that depend on mylib after mylib has been installed to the system. The install interface path is relative to the CMake install prefix, so it's generally not an absolute path. We'll also need to tell CMake which targets to install when the project is installed. You can include multiple targets in what is called an export set. Here we have one target, mylib, that is part of one export set called mylib export set. We also need to install the header files associated with the project. Including the trailing slash after the path is important. It tells CMake you want to install the files in the include directory to a subdirectory of the install location called install. We also need to tell CMake to install the export set that includes all the targets to be installed with that export set. Again, we just have one target, mylib. Along with the CMake targets, we need to install the targets.cmake file for the library. It contains the information for CMake to load the targets as if they were part of a dependent project. Lastly, for this approach to work, we need to explicitly tell CMake to install the library's config.cmake file that's used by find package to locate the library and header files of our dependency library. It's typically installed in a subdirectory of the libcmake path that's named after the library, in this case, mylib. The library project still builds successfully. But let's start over because we want to install the project and I want to show you that you can specify where to install the project on the command line with CMake. We just need to specify the CMake install prefix as a command line parameter. In this case, I want the install location to simply be within the library's own build directory in a subdirectory called install. Let's rebuild and install. To install, just call make install. You can see when we call install, it lists the full paths of every file installed to their installed location, build install. There's a new install directory in the build directory as a result. If we look inside, we see all the installed files in their proper installed locations. Now let's go back to our dependent project. Rebuilding it as is will fail because CMake doesn't know where to find the library's config.cmake file. It's not installed to a system path that CMake would search. Remember, it's in the build install directory where we told CMake to install our library. But it tells you what to do. You can either add the installation path of the library to the CMake prefix path environment variable, or provide the path to the mylib config.cmake file by setting the mylib dir CMake parameter on the CMake command line. We'll use the second option. We need to provide the path all the way to the mylib config.cmake file. Remember, that's in the build install lib CMake mylib directory. See, there it is. Oops, I mean this one. Okay, project configured successfully. And it now builds, links, and runs successfully too. Okay, the last option we're going to discuss is packaging. Let's start fresh by removing the build directory. To create an installable package, we keep all the install and export goodies we have from the last option. We just need to add the commands to tell CMake to package it all up. First, we're going to tell CMake which kind of package to generate. In this case, since I'm using Ubuntu, which is Debian based, I'm going to create a Debian package, abbreviated as DEB. Then we need to tell CMake a few things about the package. We'll give the package a description and a maintainer. Lastly, we need to include cpack. When you include cpack, the package is generated as described. We'll rebuild and attempt to install, but trying to install directly is going to fail because I'm trying to do this with user privileges and make is attempting to install to system directories that the user doesn't have access to write to. I'd have to do this with sudo if I wanted to install it this way. However, this validates that the package install location will be to the system directories, which is what we'd want when we create an installable package. To generate the package, you call make package. You can see the output from cpack indicating that a new .deb file was created. This library does not have any additional dependencies, so it's fine that cpack debian package depends is not set. There's our new .deb package file generated by cpack, CMake's packager. We can see the contents of the package using the Debian system's package command dpackage-c. This is where the files will be placed when the package is installed. You can see if the package is already installed by using dpackage-l to list all installed packages and then filtering with grep for the specific package, mylib. No output means it is not currently installed. Before we install the package, let's get rid of the existing dependent project's build directory and make sure it won't build in the system's current state. That is, with the library built, but not installed. Good, it still can't find the library. Now let's go back and install the package with sudo dpackage-i, and then attempt again to build the project. This requires administrative privileges since dpackage will need to write to system directories in order to install the files from the package. After installing the package, we look again with dpackage-l and we see that mylib-proj package is now installed. Going back to the dependent project again, if we attempt to call CMake, it's now able to find the newly installed package and configure successfully. And it will also build, link, and run successfully. Okay, one last thing. The name of the installed package comes from the name of the project. That is, if we list installed packages and filter for mylib, you'll see the name is mylib-proj. That's not the name of the library target, but rather the name of the CMake project. To purge or remove a package entirely, you can use dpackage-P. But this also requires admin privileges since it involves deleting files from the system directories. There, now the project is uninstalled. If we look again, it is no longer listed by dpackage as installed. If we clear our old build directory and try to build again, it'll fail because CMake can no longer find the mylib library when requested by find package.